So hello all. Today we'll be solving this question given in GATE 2018. Consider the min list form of a Boolean function f given below. We are given this function f of four Boolean variables p, q, r, s such that it is summation of m 0, 2, 5, 7, 9, 11 plus d 3, 8, 10, 12, 14 where m denotes a min term and a d denotes a don't care term. The number of essential prime implicants of the function f is, we have to fill in the blank. So the NPTEL video reference is lecture 6 on Carnot maps and implicants. Course name is Digital Circuits and Systems by Professor S. Srinivasan from IIT Madras. Now let us look at the useful data before solving the question. Now let us understand what is a min term. So in Boolean algebra, a product term which has a value of 1 in which each variable occurs in its complemented or uncomplemented form is called a min term. Carnot map or K-map is a method of minimizing a Boolean expression without using Boolean algebra theorems. So if we are given a Boolean expression, we need to minimize the Boolean expression so that we can realize it using minimum number of gates. Carnot map is one of the method of minimizing a Boolean expression. So what is prime implicant? A group of square or rectangle made up of a bunch of minterms permissible by the definition of K-map is called prime implicants. An essential prime implicant is a prime implicant which cannot be replaced by any other prime implicant for getting the output, or a prime implicant that no other combination of prime implicant cover the output. So we'll look at this with an example what it means. Now let us look at this example. We are given three Boolean variables. Now what the min term would mean is a product term such that each variable either occurs in its complemented or uncomplemented form such that the value is 1. So a product term means an AND operation. So if I give you these three values 0, 0, 0, what will you do such that there will be a product term such that the value is 1, which is A bar, which is 1, and B bar, which is 1 again, and C bar, which is 1 again, which will give me 1. So that will be the min term. If you look at 0, 0, 1, so 1 is already in its natural form, which is C. So A bar, B bar, C. For 2, it will be A bar, B, C bar, and so on. Now let us say we are giving this function f, which is which has midterms 0, 3, and 5, and it has two don't care terms. Don't care terms are denoted by this crosses 1 and 4. So the Boolean function is written like this, and we can write the Boolean expression in the form of this, which is summation of the min term 0, 3, 5 and don't care term 1, 4. We write the don't care term so that it helps us in minimizing the Boolean expression. Now this is what is called a K-map. A K-map is a map where in this case the rows denotes the variable A, which can take two variables 0 and 1, valued 0 and 1, and the columns denote BC, which can take four values 0, 0, 0, 1, 1, 1 and 1, 0. Notice that if we move from one column to the another column, there is only one bit change. So from 0, 0 to 0, 1, only one bit changes. From 0, 1 to 1, 1, only one bit changes, and from 1, 1 to 1, 0, only one bit changes. Now we were given this Boolean formula, Boolean function, so we have represented it in the form of a K-map. So to read the K-map is A is 0, BC is 0, 0, so it's 0, 0, 0, so this number is 0, this cell is 0. A is 0, B is 0, 1, so it is 0, 0, 1, this cell is 1. A is 0, BC is 1, 1, so it's 0, 1, 1, which is 3. And A is 0, BC is 1, 0, which is 2. Similarly, 1 is A, BC is 0, 0, so it is 4. 1 is A, BC is 0, 1, so it is 5. So we mark the respective numbers, so 1, x, 1, 1, x1, and we try to find the biggest quad or octet or pair as possible. In this case, one pair we can find is this, which is one quad, which is 1 and 1, these two mixed up using this min term, the don't care term. Another is pair we can form is this. So these two are called prime implicants, which is we are trying to cover a min term using the definition of K-map. Right? Now you might ask me what will be essential prime implicant. So here the essential prime implicants are nothing but the prime implicants itself. But let's say if this number, let's say 2 would have been 1. Okay. Then what would have happened is, one minterm I could have formed is this, one pair I could have formed is this. I can group this and this, which makes it one minterm, one prime implicant, or I could have made this as a prime implicant. Okay. But if you see, if let's say I take this as a prime implicant, then this prime implicant, the one that I have circled, this one, right? It covers a minterm which is already covered by some other implicant, and it is not covering any unique minterm. Okay, so what minterms are covered by this pair, which is one is this one, another is this one. So this one, the first one, is covered by this quad, and while this one is covered by this implicant, prime implicant. So this pair, that is this pair, is not an essential prime implicant, but it is a prime implicant. Okay, I hope you understand it. So if I remove that one, so I have two number of prime implicants, which is uh, this octet and this pair, while I have same number of essential prime implicants. Now let us come back to our solution. Now we are given four variables PQRS. I have written is ABCD 00011110 and we try to form the maximum possible pair or octet depending on the definition of K. So one is this pair that we form, right? One is this quad that we can form using the corners, using the don't care terms, and one is this quad that we can form so that it covers these two variables, right? So the number of essential prime implicants is 3, right? 1, this quad 2, and this corners 3. We don't have to map the don't care term, because as we call them don't care, so we don't care about these terms, they just help us to minimize the Boolean expression. So the essential prime implicants of this function is 3. I hope you all get it. Thank you.